So welcome to this latest video 162 Maths, and in this video we'll be going over the AS Maths Mechanics Kinematics topic of using SUVAT for vertical motion. Now when it comes to vertical motion under gravity, gravity is a force, and the force of gravity on an object causes it to accelerate or decelerate. Now basically what that means is if an object is going up, then what will happen is that the object will be de-accelerating because it is going against gravity, and whereas an object is going down, it's going to be going with gravity, in which the object will be accelerating. Now on Earth, acceleration due to gravity is measured as a value to 9.81 meters per second squared, and is given as the letter G. Now if you do A-level physics, then gravity is going to be fixed as 9.81. However, in maths and in mechanics, gravity can be given as different values. Now, a question will ultimately tell you what value of G to use, whether it be in the question or on the front cover of your exam paper, in which gravity can either be a value of 9.81, 9.8, or even 10 in some cases. Now, you must use the accuracy given in the question, and like I said, typically a question might ask you to use a certain degree of accuracy in your answer, in which what you want to do is follow the accuracy of your gravity value. So if gravity is given as 9.81, then you want to give your final answers 2 decimal places. If it's given as 9.8, then you give your answer to 1 decimal place. And it's really important that your answer must be given to the same accuracy, because that is what the mark schemes and what they will be expecting. Now, just like with horizontal motion, there are some modelling assumptions that must be applied by when it comes to vertical motion under gravity. And those assumptions are that gravity is going to be constant, so it's never going to be changing, and that air resistance can be ignored. So just like with the particle motion, you don't really want to take in factors of size or weight or mass. It's just a case of ignoring it. Now, yes, in the real world, these things would have a factor, but just to save a bit of ease of calculation, you can ignore this. Now, some questions will ask you what assumptions have been made, in which what you can see on the screen now are the 2 popular assumptions that you want to be writing for those marks. Now, when you are dealing with horizontal motion, that we usually have taken right to be positive and negative to be going in the opposite direction. Now, with vertical motion, there is no set direction for positive and negative. Now, what you do want to do is, because obviously we do need to take these on board with regards to the sign, is that we take the positive direction for velocity and displacement to be the direction of the initial velocity. So in other words, if a ball or a stone is being thrown up, then anything going up will be positive and anything going down will be negative. If a stone or ball is being dropped, then anything going down, because that's the lateral direction or the initial direction of the stone, will be going down will be positive, and anything going in the opposite direction will be negative. And it's really important that you get your head around that, and sometimes by drawing a diagram it kind of helps with regards to that. So just to summarize, so if a ball is being thrown up, then the gravity value or the acceleration value that we're going to be using will be minus 9.81, as the gravity is pushing down on the ball. And if a ball is being dropped, it's going in the same direction as gravity, so therefore it will be positive. So let's have a look at this first example. So this first question says that a small ball is thrown downwards from a window 4.6 meters above the ground with initial velocity of 1.2 meters per second. Air resistance can be ignored. Use G equals 9.8 meters per second squared, giving your final answer to appropriate degree of accuracy. And what this question is asking us to find is A, how long it takes for the ball to reach the ground, and B, how would your answer be affected if air resistance was included. Now, when you're starting these particular questions, I always find it really useful to draw a diagram, in which you'd end up with this here. Now, the only thing that I'm missing from this diagram is what direction the gravity is going to be facing. Now, gravity is usually expressed with a line with 2 arrows, and the ball is traveling with gravity, so that's going to be plus 9.8 meters per second squared. And likewise, S is going to be positive because it's going in the same direction as gravity. Now, if we start these particular questions by stating our SUVAT, and this is part A that we are looking at, so we've decided that S is going to be positive because it's in the same direction as gravity, which is going to be 4.6 meters. Our initial velocity is as stated in the question, is 1.2 meters per second. Our final velocity we don't know, and our acceleration is positive 9.8 meters per second squared, and the question's asking me to find the time, which I'm just going to call x. Now, what's really important with these questions is that when it comes to the final velocity, don't write 0. The final velocity is basically the final speed in which it is going to be hitting the ground. And the key thing, concept to this is if the ball is accelerating, which in this case it is because it's going with gravity, you can't accelerate to 0. So that's why your final velocity can never be 0 when it comes to these particular questions of it being moved down. It would be, however, when we look at some other examples where the ball is being thrown up, it then goes to a point of stationary, and then it then changes direction and therefore changes acceleration as well in terms of our velocity. So anyway, back to this question. So what we're trying to do is we know S, U, A and T, and we're trying to find out what T is. So we then need to do select the correct formula, in which I'm going to go for this one here. So therefore, using S equals UT plus a half AT squared, what I end up when I substitute the values in, I end up with 4.6 equals 1.2 T plus a half times 9.8 T squared. Now, one thing I did forget to mention is when you've written your SUVAT, always check for consistency of units. So make sure that your time units are all the same. Make sure your distance units are all the same. So in this particular question, we've got meters for distance and seconds for time, and it's just worthy of just making sure that, because obviously if there is a difference, we will then need to convert those so that they are all the same before working out and using our SUVAT. Back to the question then. So simplifying all of this, I end up with 4.9 T squared plus 1.2 T minus 4.6 equals 0, and that then becomes a quadratic equation. Now from this, what I then want to do is solve that quadratic equation, in which I will end up with an answer of 0.8541 or minus 1.099. Now from this, we can't have negative time, so I can rule this particular answer out. I'm just going to write reject. Now when you do solve a quadratic, odds are you'll have two values. If you do have one that is invalid and can't be the actual answer, always make sure that you include it in your answer, but then you symbolize it by either rejecting it or put a line through it, or explaining the fact that you can't have negative time before going to your final answer. And this here would be my final answer. Now all that's left for me to then do is just round that answer to a suitable degree of accuracy. Now most of the numbers in the question are rounded up to 1 decimal place, so we can then round this answer to 1 decimal place. I'm just going to write 1 dp, and there is my final answer. Now for part B, it says, how would your answer change if air resistance was included? Well, if air resistance was included, it would act against the ball dropping. So for B, it would increase the time. Or that your answer in part A would be increased. So something along those lines would be absolutely fine for B. So now let's have a look at our second example. So it says the ball is thrown vertically downwards with a given initial speed. Assume that the air resistance can be ignored and that the ball does not reach the ground. Find the speed and the distance travelled by the ball at the specific time. So here we've got two parts of the information. We know the initial speed and we know the time. So for this, we've got a ball that is being thrown downwards, and we've been given the information by the factors in part 1. Now as a ball is being thrown down, it's acting with gravity, so it's going to be plus 9.8. We can use our own sort of value for this, as it's not mentioned, but we're looking at this, we're given to 1 decimal place. I'm going to use 9.81. So it's worth just saying that we're going to use G equals 9.8. Now again, you can make some assumptions on this. If you do get this type of question in the exam, I would always check the front cover to make sure they've not given you a default value of G. Typically in a question it would state it like it did in the previous example, but if it didn't, I would always recommend students to write down what value of G they're going to be using. Anyway, back to the question. So for question A, if I start by writing my SUVAT, then for this I've got an S value and I don't know what that is. My initial speed is 23 meters per second. My V, I don't know. My acceleration is positive 9.8 meters per second squared, and my time is 0.8. And what the question is asking me to do is to find the final velocity and the distance. So it's asking me to find V. So whenever it asks for speed, it's always the final velocity. And I also need to find S. So I need to find the two things. So let's just call that X and let's call that Y. So for part A, finding X, I'm going to use V equals U plus AT, in which then I get a V equals 23 plus 9.8 times 0.8, and I get a V value of 30.8 meters per second, and that's to 1 decimal place. I then need to find S. So to find S, I'm going to use S equals UT plus a half AT squared. Let me just make that a little bit clearer as to what I've done here. There, so I can now write V as 30.8. Now, as I've got 4 variables, I can use any formula. To find S, I can use any formula that uses S. Now, depending on how confident you are in your previous answer, so if I'm really confident of using V of my answer in the first part, I could use it. If you're not confident, then use the values that have been given in the question that you know for fact. So just to bear in mind of just seeing how confident you are in terms of those answers that are being used. So from this, using this formula, I get S equals 23 multiplied by 0.8 plus 0.5 multiplied by 9.8 times 0.8 squared. Then if I type that all into my calculator, I get an answer of 21.5 meters, and that's to 1 decimal place. Now for part B, I just need to repeat the process. So for B, if I start by writing my SUVAT, I'm then just replacing my method for part A in terms of the formulas used. So for part B, my initial velocity is 0, my time taken is 6, and the A value is 9.8. Now again, substituting those values in the correct same way. For B, I should have a V value of 58.8 meters per second. And for S, I should end up with a value of 176.4 meters. And each of those answers are given to 1 decimal place. So looking at our third example, it says that a stone is thrown upwards with a velocity of 6 meters per second from a platform 1.2 meters above ground, using G as 9.8 meters per second squared, giving your final answer appropriate degree of accuracy. And questions A, B and C and D are asking us to find the velocity of the stone in which it hits the ground, the greatest height above ground, how long it takes for the stone to reach the highest point, and for how long it is falling for. Now for this particular question, we've got 2 separate parts. We've got one part where the stone is going up and then one where the stone is going down. So how I'm going to set this question up is if I have the stone going up, and I start by writing my SUVAT values, in which I'm just going to call that stage 1. So that there, and then I've also got stage 2, which is when the stone is going down, in which I'm going to call that S2, U2, V2, A2 and T2. Now let's have a look at what information we know. Now for when the stone goes up, I know that the initial velocity is 6 meters per second, and I know that the final velocity, which is when it goes up to where it goes to its highest point, is going to be 0. I also know that the acceleration is going against gravity, so that's going to be minus 9.8, and that's as much information as I know for that. Then for the stone going down, I know that the initial velocity is the same as the final velocity in the previous stage, so that's going to be 0 meters per second. I know the acceleration is going with gravity, so that's going to be 9.8 meters per second squared. Let me just add the units for that. And that's pretty much it. Now for part A, it's asking me for the velocity when the stone hits the ground. So what it's asking me is to find V2. Now looking at the stone down sort of information, I only know 3 bits of information and I need to find the 4th. Now I can find S2 because what I know is that S2 equals S1 plus 1.2 meters, because it tells me that the platform is 1.2 meters above the ground. So what I'm needing to do is to work out the S1. So if I just keep that in mind there, so to find S1, what I can then use is I'm going to use V squared equals U squared plus 2AS. Now using the stone going up data, then what we end up with is we're going to end up with V squared minus U squared over 2A equals S. So therefore S1 is going to equal 0 squared minus 6 squared over 2 times minus 9.8. Now from that I get an S1 value of 1.8367. So therefore S2 is going to be S1 plus 1.2, giving me an S2 value of 3.0367. So I can now write this in this section here. And I can also, for S1, I can now write that that's 1.8367, and both of those are in meters. Now from this, what I can then do is I can now got my third variable, and I can now work out what V2 is. So for part A, using V squared equals U squared plus 2AS, and using the information from the stone going down, I get V squared equals 0 squared plus 2 times 9.8 times 3.0367, in which I get a V squared value of 59.52. So V is going to equal the plus minus of that answer, in which I get a V value of minus 7.71 meters per second, or 7.71 meters per second. Now because when the stone's going down, it's going against the initial direction of the stone, which was going up and then down, the answer that we want is going to be the negative version. So I just need to put a line through this, and again the reason why we're choosing minus 7.71 is because it's going against the initial velocity of the stone being thrown up. So this is going to be my answer for V2. And again, you can choose why you want to write it. So I'm going to write it to 1 decimal place, and there's my answer for that. Now moving on to question B. Well, question B says, what's the greatest height above the ground? Well, for B, it's going to be S1 plus S2. Well, actually, it's not going to be S1 plus S2. It's going to be all of just S2. And so that answer for B is what I've already worked out, which is 3.0367, which will just give to 1 decimal place. So it's 3 meters to 1 decimal place. Then for part C, it's saying how long does it take for the stone to reach its highest point. So for this, we're just trying to find T1, and which I'm using that information there. So I'm going to use V equals U plus AT, in which T equals V minus U over A. And substituting those numbers in, I get 0 minus 6 over minus 9.8, which gives me a T value of 0.6122, which equals 0.6 seconds, and that's to 1 decimal place. So I can write T1 as 0.6 seconds. Then for part D, it's just asking me to find T2. So for T2, again, what I'm going to do for this one is I'm going to use S equals UT plus a half AT squared, and using the information from the stone going down, I'm going to get 3.0367 equals 0 times T plus a half times 9.8 times T squared. And simplifying all of that, what I end up with is 3.0367. Now if you've rounded up your numbers, that's fine, but I'm just going to go for as much accuracy as I possibly can, in which I get this. So T is going to equal plus or minus the square root of 3.0367 over 4.9, in which I get a T value, and it's going to be a positive answer, which is going to be plus or minus 0.787. So T2 is going to equal 0.8 seconds. And there is my answer for part D. Now for the next example, it says in this question use G equals 9.81 meters per second squared, giving your answer to an appropriate degree of accuracy. A ball is thrown vertically upwards from the ground level with a speed of 18.5 meters per second. And the question is asking us for part I, is asking how long does the ball take to reach the height of 15 meters, and for part 2, it's asking for the speed of the ball at this time. So let's have a look at what this particular scenario looks like. So here we have the ground, and the ball is being thrown up, and it's then coming down. So for this, let's have a look at this. So here we've got start off by writing our SUVAT, in which S I know is 15 meters, which is given there. We know that the initial velocity is 18.5 meters per second. We don't know what the final velocity is. Acceleration is going against gravity, so that's going to be minus 9.81 meters per second squared. And T is what I'm wanting to know. So let's have a look. So for part I, what I'm going to do is I'm going to use UT, or S equals UT plus a half AT squared. So from this I can then substitute numbers in. So I've got 15 equals 18.5 T plus, and then it's going to be minus 4.9 T squared, doing a bit of simplifying. And that gives me a quadratic equation of 4.9 T squared minus 8.5 T plus 15 equals 0. Now solving this, I get a T value of 1.18 or 2.6. Now each of those seem particularly valid. Now the difference is the fact that with this particular question, we don't know what the actual height of the ball is being thrown. All we know is that when it hits 15 meters. Now, as you can see from the diagram, that it's actually hitting at 2 particular points. So it goes on the way up, it bypasses that 15 meter mark, it hits its peak, and then on its way down it goes past that 15 meter peak, and not peak, that distance, and then it comes back down. So this will be the time of the ball to hit the height of 15 meters first. So for part I, the answer is 1.18 seconds, and that's to 2 decimal places. Then for part 2, it's then asking for the speed of the ball at this time. So for part 2, let's just get rid of all of this. And I can write my answer to this as 1.18 seconds. It then says the speed at this time, so this is now what I'm looking for, and I know that the time is now 1.18 seconds. So then using SUVAT again, actually no, I can already written that. So for this, to find out what x is, I'm going to use v equals u plus at, and substituting numbers in, I get v equals 18.5 plus, and it's going to be minus 9.81 multiplied by 1.18. Now if I type that all into my calculator, I get an answer of 6.92, and that's meters per second, and that's to 2 decimal places. And so that's my answer for part 2. Now moving on to our next example, it says that a stone is thrown vertically upwards from the top of a cliff with a speed of 10 meters per second. It hits the sea below with a speed of 33 meters per second. Find the time taken, and we can use g is equal to 9.8 meters per second, and we want to give our final answer to an appropriate degree of accuracy. So let's have a look by first just drawing a little diagram to represent this sort of scenario. So here is my cliff. We've got the water below, and this stone is being thrown up, and then it comes back down. So we know that the initial speed in which it's taken off is 10 meters per second, and we know that the speed in which it hits the sea is at 33 meters per second. So with this, we've got a two-step scenario. So we've got the stone going up, and we've got the stone going down. So if I start by writing my SUVAT, and the same for the stone going down, we can then start filling in the values. So for the stone going up, we know that the initial speed is 10 meters per second. We know that the final velocity is 0, and we know that the acceleration is going against gravity, so that's 9.8 meters per second. And for the stone going down, we know that the initial velocity is 0, the final velocity is 33 meters per second, and we know it's going with gravity, so that's going to be positive 9.8 meters per second squared. And what the question is asking me to do is to find what the total time is. So I need to find out what this value is, and I need to find out what this value here is. So to find, if I call it T1, what I'm going to do is I'm going to use V equals U plus AT, in which V is going to equal, well, I should say T is equal, because that's what I'm trying to find. So T equals V minus U over A. So T1 is going to equal 1.18 0.0204 just to save a bit of time. If I then repeat it for T2 using the same formula, then I get a T2 value of 3.3877, and then so the total time is going to be 1.0204 plus 3.3877, which gives me a total time of 4.39 seconds. And looking at the degree of accuracy, let's give it to 1 decimal place, so it's going to be 4.4 seconds, and that's to 1 decimal place. Now, it is possible to do this particular question in one step. Now, to do this in one simple step, what you need to do is really get your head around in terms of the signs of what we're looking for. So if I use my SUVAT in one step, now for this, the initial velocity is going to be 10. We know that the final velocity was 33 meters per second, but that's going in the opposite direction of the initial velocity, so that's going to be minus 33. And then the acceleration for the final step is going to be minus 9.8 meters per second. Now the reason why it's minus 9.8 is because the final velocity is going against our initial throw. So our initial gravity is going upwards because that's the first stage, and that's going against gravity, so that's why it's minus 9.8 meters. And then from this I can then use the formula of T equals V minus U over A as I did for the others, and typing that all into your substituting it in, I get T equals minus 33 minus 10 over minus 9.8, which will give me the same T value of 4.4 seconds, and that's to 1 decimal place. So if you're able to get your head around it, you can do it in one step. However, if you're not too sure, take it in 2 steps. It might require a little bit of extra working, but eventually you will get there.